So here's our other example of one of the hard log solves. So this is number 68 in 11.3, and we're supposed to solve log base 5 of 3x plus 1 equals 2. So what's my first step? How do I get rid of the log base 5? I'm going to put 5 underneath both the sides, right? So that's me applying the 5 to the whatever function to both sides. So I get 5 log 5 raised to the quantity log base 5 of 3x minus plus 1 equals 5 squared. Oh, that's 25. Cool. Sorry, let me write that so I don't confuse you with the weirdness of the 2's. So that's 5 squared, which is 25. Cool? All right, now why did I do that? Because the log 5s will cancel. So the log 5 will cancel with the 5 on this side. And I'll get 3x plus 1 is 25. So then what do I do to both sides? So I subtract 1, I get 3x is 24. Okay, so we divide both sides by 3. We get x is 8. And in the process here, we constructed the inverse function for this left-hand side. So if I wanted to, I could notice that if f of x is log base 5 of 3x plus 1, f inverse of x is 5 to the x minus 1 over 3. Very nice.
And you want that step on there also?
I don't care if you put this step on here. If I ask for it, I would like you to use it. Does that make
What
sense?
would that step be called?
So this would be find the inverse of f of x equals log base 5 of 3x plus 1. You can do that with the bubbles, or you can give yourself a number and solve. You guys see that? So if you wanted to find an inverse function without using the bubbles, you really could just set it equal to some number, say 7 or whatever, and solve for it. You'll get some horrible fraction usually, but your inverse function will be just written down the side there. Okay, see that? So solving and inverting are not different operations, right? They're two sides of, well, they aren't even two sides. They are the same thing. Cool. It's just a different perspective, maybe. Cool?
Okay.
We want to try another one?